All right, today we're cracking open the AI black box. We're going to look at a brand new tool that gives us a much sharper view of how these incredibly complex systems actually think. So let's get right into it.
I mean, think about it. We are handing over huge responsibilities to AI. We're talking about transformer models, the brains behind things like ChatGPT and Gemini. They're everywhere, and they're doing some seriously heavy lifting for us.
And that's the real question, isn't it? This is the whole problem of AI interpretability. If an AI is making a critical call, say in medicine or finance, we have to know why. But right now, it's basically a black box. We get an answer, but we have no idea how it got there.
So, to really get why this new approach is such a game changer, we first have to understand the tools we've been using up until now to peek inside that box.
For a long time, our best guess came from something called attention maps. They're basically these heat maps that show us which words or which parts of an image a model is focusing on. And they've been super useful, but here's the catch. They only show a tiny part of the picture.
Right, so attention is just one component. The model is also running these massive calculations in its feed-forward networks. It's doing layer normalization to keep things stable. And it's using these things called residual connections to pass information along. All this other stuff is happening under the hood. And standard attention maps, they miss all of it. It's literally like trying to figure out how a car works by only looking at the steering wheel.
You know, the researchers behind TensorLens put it perfectly here. We've been stuck with these incomplete partial views. What we've been missing is that one single, unified picture that shows us everything the model is doing from start to finish.
And this is where the big idea, the real breakthrough, comes in. They came up with a totally new way to look at the entire computation that a transformer does.
And that is TensorLens. Now, I know, that definition is a bit of a mouthful, but the concept behind it is just so elegant. Instead of trying to track dozens of separate steps, they found a way to mathematically combine the entire model into one single, unified object, a tensor.
And boom, this is the aha moment right here. Look at the left. That's the old way. You've got this long, complicated chain of operations, one block after another. But on the right, that's the TensorLens view. It takes that whole chain and represents it as one single, powerful operation. One massive tensor that tells you exactly how any piece of the input influences any piece of the output. It's just clean.
So, you're probably wondering, how on earth do they actually build this thing? Okay, let's dive into the math, the actual blueprint for creating this lens.
Think of this diagram from the paper as our roadmap. You can see how they take each little piece of a transformer block, the self-attention, the layer norm, the FFNs, and they convert each one into its own tensor operator. See the A, L, and M? Then they compose them, basically multiply them together to get one tensor for that entire block. And they just keep doing that for every layer in the model.
Let's zoom right in on that. It's beautiful. So first, they tensorize each part. You've got A for attention, L for layer norm, and M for the feed-forward network. And that little plus I, that's the crucial residual connection, the information shortcut. Then they just stack them all together using this one equation. The result is a single tensor, T, that perfectly, mathematically, describes everything that one whole block does. It's the complete picture.
Okay, so the theory is elegant, the math is beautiful, but does it actually work? Does it give us better insights in the real world? The researchers ran two really smart experiments to find out. So the first test is just genius in its simplicity. It's called a perturbation test. The logic is, if your tool is actually good at finding the most important inputs, the most critical pixels or words, then if you start deleting them, the model's performance should fall off a cliff, right? The faster it crashes, the better your tool is at finding what truly matters. So they set up a direct showdown. In one corner, you have the old methods, which basically just guess by averaging a bunch of attention maps together. And in the other corner, you've got TensorLens, using its complete, unified view to pinpoint the most critical inputs.
And wow, the results really do speak for themselves. Just look at these graphs. That bright orange line that's consistently higher than all the others, that's TensorLens. It means that when you remove the inputs that TensorLens flags as important, the model's error rate just skyrockets, way faster than with any other method. It is, without a doubt, flat out better at finding the model's pressure points.
But they didn't stop there. The second test goes even deeper. It asks, can this lens do more than just find important stuff? Can it actually help us approximate the model's internal logic?
They tested this on a task called relation decoding, like figuring out if the model has learned that a doctor works at a hospital.
And yep, another huge win. This chart sums it up nicely. The approximation you get from TensorLens was significantly more accurate at mimicking the model's internal reasoning compared to another really strong method. We're not just seeing what the model looks at anymore, we're getting a real glimpse into how it's actually thinking.
So, what does this all mean for the future? Well, this isn't just some small, incremental improvement. This feels like a genuine turning point for AI clarity. What this unified view gives us is a fundamentally stronger foundation to build all our AI explanation tools on top of. It's a much more precise instrument. And maybe best of all, it's designed to be a drop-in replacement for the old attention methods. Ultimately, this is a huge step forward on the path toward building AI that we can genuinely understand and therefore genuinely trust.
And you know, the best part for all you developers and researchers watching, the team made it all completely open source. The code is up on GitHub right now. You can go download it and start using it to analyze your own models today.
Which leaves us with this one big, exciting final thought. For so long, we've been trying to understand these powerful AI minds by peeking through a foggy, blurry keyhole. Now, with a tool like TensorLens, we have a much clearer window. So the question is, what are we going to see when we finally take a good, long look inside?